tools have been already developed, some others are on their way. So we don't have, let's say, a final evaluation of the results yet because we are at the end of the first year of the project. At least we have some ideas of where to go, and this is what I'm going to present. Sorry for the strange fonts. I copied my presentation from my computer to this one, and it seems that there is some problem. I hope you can read what is written. So, what are the project goals? First of all, MODAClouds helps in the process of design and operating a multi-cloud application. So an application that is run on multi-clouds environment that can be composed of infrastructure as a service environment and platform as a service environment. It offers a framework for design, a language for design, and an automated decision support system to support the decision-making process and the planning environment. And provide guidance through the development, monitoring, migration processes. So the main targets are these two guys here. That are the application developer and the application operator. Don't ask me why the application developer is so nice and the application operator is so ugly. So, what are the benefits that we aim at offering? First of all, we want to avoid vendor lock-in, and we want to do so by enabling application developers and operators to use different multiple clouds, and to be able to exploit IaaS and PaaS in different ways. And the other one is that we want to be able to handle cloud outages. Basically, through the idea that if our applications can be run on different clouds, if one goes down, then we can use the instances of our application on another cloud to continue running. And our approach is based on the usage of a model-driven set of languages and tools that enable us to build the application in such a way that it is visible to the so, what is the meaning of multi-cloud for us? We have at least two different aspects of multi-cloud. The first one is that we have our application, we have different clouds that are MICAS or IaaS, and we should be able to deploy our application on these different PaaS and IaaS so that the application can run anywhere. Of course, clearly the application that is executed here, and here may be different from the code perspective, but the idea is that the design of our application should remain the same, and our approach should support the process toward the deployment of the application on different kinds of clouds. And we are experimenting different ways of doing so. The second idea that we have on multi-cloud allows us to handle outages, as was mentioned before. Here we have an example of an application that we call Smart City Planner. This is the application offered by one of our end users. And the aim of this application is to make sure that if there is an emergency in the city, this emergency is captured through a network of sensors that are distributed to the city, and the Smart City Planner is able to understand that an emergency is occurring, for instance a fire or any other possible bad situation that can happen, and the some decisions such as asking the electric company to stop the distribution of electricity in an area in which, for instance, it is fire, things like this. Of course, you want to make sure that this smart city planner is always available and able to manage any kind of emergency, and therefore we keep a second instance of this smart city planner in a different cloud, and we make sure that the data of this instance and the data of this other instance are kept synchronized, so that in case there is a problem, it is easy and fast to switch from one instance to the other instance, so that the application itself will continue to be always available for use. So this is the overall, let's say, architecture of MODAClouds. We have a design time set of tools that we call MODAClouds integrated development environment, and then we have a runtime infrastructure that basically supports the execution of application, the monitoring, data synchronization, and also self-adaptation of the application on multiple clouds. At the level of the design, we support the model-driven approach. We have 3 layers in our model-driven approach. The first one is called cloud-independent model layer, and then cloud provider-independent model layer. In this case, we introduce cloud-dependent concepts, such as, for instance, message queue or large memory resource or high-performance virtual machine, but we do not refer to a specific cloud provider. While here at the bottom we have the cloud provider-specific model layer, in which we refer to specific cloud providers on the board, for instance, to the message queue offered by Google, to the spot instance virtual machine offered by Amazon, etc. And the idea is that we guide the application developer in going through these layers. So starting from the upper layer, in which the application is designed in terms of the functionality that it has to offer, in terms of the quality of service requirements, and then this set of layers. Application developer is guided in the selection of the right cloud concepts that could be helpful for the application, and then in the selection of the right providers that could support his quality of service requirement. So this is a more detailed view, even though not as nice as the previous one, of the architecture of this part, so the design time and the runtime. In particular, the MODAClouds integrated development environment is composed of a set of tools that are listed here. I will go into the details in a minute. And then here we have the runtime platform that is composed of the monitoring platform, the self-adaptation platform, and the execution platform. As we were saying before, the purpose is to be able to handle multiple clouds and execution of the application on multiple clouds. So going back to the integrated development environment, this is composed of tools to support the functional modeling of the application, the different layers of abstraction, of our model-driven approach, the decision-making toolkit, that is the one that supports the user in identifying the requirements for the application and in understanding which set of candidate clouds can be more suitable for a certain cloud application. Then we have here the quality of service modeling and analysis tools that allow us to define quality of service requirements for our application and to understand if a certain configuration of a certain cloud for that application fulfills the requirements that we have or not. This tool also offers some optimization mechanism that allow the user, the developer, to visualize the configuration that according to the tool is the best one, given certain requirements. Then we have the deployment and the provisioning component, that is the one that through which we define the way our application should be deployed on a certain cloud or a certain set of cloud. And this component is basically the one that generates the initial deployment model that is then given to the runtime platform as an input for starting the execution of the application. Then here we have this data mapping component that is useful to understand how to map the design, let's say the data model, the high-level data model of our application into the specific data storage technology that is offered by a certain cloud provider. All of these tools here are integrated through these shared models. Here we have a set of models describing the application from the functional and non-functional perspective that are shared by all the tools and that allow these tools to interoperate. And then these models here are those that are produced as output by the MODACloud and enters into the runtime platform. So we have monitoring rules that are generated based on the quality of service requirements that we have defined, so that we can monitor at runtime that the quality of service requirements are actually fulfilled by the actual execution of the application. We have here policies for self-adaptation that are the ones that allow us to transform the deployment of our application in such a way that it can fulfill the quality of service requirements in case there has been a violation. This is the initial deployment model that I mentioned before. We have the quality of service model that allows the monitoring platform to understand if the actual execution is actually fulfilling these quality of service requirements, and then we have the deployable artifacts that are the pieces of code and executable that we need to actually in the runtime platform. And here, as I said, we have the three main elements of the runtime platform, that are the execution platform, the platform, and self-adaptation. Let me provide a few more details on the workflow that is developed within the MODAClouds Sweden. So we have this tool, or this tool set, I would say, allow us to perform the requirement engineering phase. In this phase, the decision support system is the one that is playing the major role by allowing us to analyze various alternatives also of cloud service candidates for our application. Then we have, and this is also related to the risk and cost analysis phase. So we try to understand the risk of making a certain choice and the cost of that same choice in terms of cloud resources. Then we have the application data and data design, the realization of the components, so the software. We have the specification of the deployment. Here, in parallel with the functional design, we have the quality of service analysis and modeling. And in the end, we deploy our application. And we have this language that is called cloud